Hey there, welcome everybody for today's lesson on partitioning a directed line segment. This is part one of two lessons we're going to cover on this topic. So the question that we're eventually going to answer is how do we determine the exact point that partitions a line segment at a specific ratio? So there's a lot of maybe some new stuff in there and some things we haven't talked about in a while. We're going to eventually learn how to do this. It's going to take us a couple lessons to get there. But this is its own specific standard about partitioning a line segment. We're going to first start by defining what that word means in a moment. But first, let's do a warm-up. Okay, so we have this line segment here, AB. Let's just imagine we were asked to find the midpoint. Okay, so let's do a little review here. So A is at -4, 5, and then B, if we count that out, is at, looks like it's at 12, 13, right? Okay, so we can do our midpoint formula here. We can find the average basically of these points, right? So we could say M would be at what? It would be at -4 plus 12 divided by 2. That's adding the x coordinates dividing by 2, and then 5 plus 13 divided by 2. So if you simplify those out, you're going to get 8 over 2 and 18 over 2. And then you're going to get 4, 9, right? And you can kind of tell you're right for a couple reasons. If you go and plot this point, if we go to 4, 4 is right here, and then we go up to 9, you can tell that we hit the line. So it's a pretty good indication that we did this correctly, that our midpoint is at 4, 9, okay? All right, now watch how it changes here. So now they're asking us, find the point that lies on AB that is 1/4 of the length. So instead of the midpoint, which is 1/2 of the length, right? Midpoint would be like 1/2. They want us to find point F, which is 1/4 of the length, okay? So let's try to think of a creative way to do this. If you think about money, if this is like 0 and this is $1, right? M would be like 50 cents basically. So 1/4 would be like a quarter. So where's a quarter in this whole process? Well, it's right in the middle between 0 and 50 cents. So what you can do here is if you want to figure out the point that's 1/4, what you could do is you could basically just apply the midpoint formula, but instead of applying it to A and B, apply it to A and M. So why don't you pause here and do the midpoint formula between point A and point M. Okay, and you saw the math just kind of pop up on the screen here. So point F you should have been able to find at 0, 7. And again, we're going to be confident we're correct because it falls on the actual line. All right, let's do one more here. So number 3 now is asking us to find the point that is 3/4 of the way, and we're going to call that T. So based on what we did last time, if F was over here at 1/4, if M was 1/2, well then 3/4 is going to be right in between M and B, right? So do the midpoint formula between M and B, and that will give you the location of point T. Pause it here. All right, here's the work popping up. So what you should have gotten is T located at 8, 11, all right? And you can kind of see just visually here that we've broken up into this line into equal parts here, right? So we had a full line, we cut it in half, we cut it in 1/4, we cut it in 3/4. And we're able to do that with the midpoint formula every time because pretty much you're just taking 2 points and finding the middle. Now, this final question here of the warm-up is really getting into what this lesson's talking about. What if we were asked to find the point that was 2/5 of the length of AB? Well, we could no longer use the midpoint formula because we're not looking at a place that's directly in half. So we would need a new skill to find the point that cuts this line at 2/5. In other words, the point that partitions this line at a fraction of 2/5. So that's what we're going to learn about how to do today. But if we wanted to estimate it, 2/5 is a little less than 50%, but it's more than a quarter. So probably we'd be somewhere around here, right? We're going to be somewhere in this range is going to be 2/5. Not exactly, but somewhere. Okay. Let's talk about what partitioning means. So what we can do is we can use ratios to partition lines, and partitioning lines means to divide segments proportionally. So when we partition something, it just kind of means we're cutting a line at a specific proportion. We're dealing with what we call directed line segments here. That just means we have a specific starting point. So if it's line AB, that means we start from A and go to B. You'll see where that will become important. What we're going to do here is we're going to examine two examples of partition line segments, and I want to really point out the difference between the ratio and the fraction. That's where we're going to spend a lot of our time today. Okay, let's take a look here. So let's just look here on the left side on this first one here. So notice it says point P partitions AB in a ratio of 2 to 3. So what you can see here is P is splitting this line up, AB, into 2 parts to 3 parts, right? So 2 to 3, that's the ratio, 2 to 3. Notice this becomes the fraction 2/5, right? If you think about how many parts is this 2 out of the total? Well, the total is 5, right? So you're going to have to be very fluent with going between ratios and fractions when it comes to these types of problems. Similarly here, I'm going to this next one here now. Point P on this one partitions it into a ratio of 3:2. So 3 to 2, 3 parts to 2 parts, right? Well, that's going to be a fraction of 3/5 because it's 3, this 3 here, out of the total, which is 5, okay? So we want to be able to use both. We want to be able to think about both, but often what you're going to find is that the fraction is the more important element. That's the one we're actually going to use mathematically. Okay, let's get a little more comfortable with ratios before we move on. So we're told here point X is located a sixth along the way of segment AB, right? So it cuts AB into a ratio of blank to blank. So we want to figure out from this fraction, what's the ratio? If we draw a line segment, I think that will help us visualize this, okay? So if this is AB, we don't even have to be very precise. We can just kind of estimate it. So if X is 1/6 along the way, that means it's going to be closer to A. And so you can think of it this way. A to X, that has to be 1. A to B would have to be the total distance, so that's going to be 6. That's the denominator of this fraction, right? So that means what's X to B? 5, because 6 minus 1 is 5. So the ratio, a 1/6 fraction creates a ratio of 1 to 5. See how that works? Okay, similarly, this is like almost the reverse on the next one. Point G divides line segment EF into the ratio of 3 to 4. So here, they gave you the ratio. Instead of giving you the fraction, they want us to find out the fraction. So here's EF. And so G is making it into a cut of 3 to 4. So that means this is 3, this is 4, right? Because that's the ratio. So what's the fraction? Well, just think about the fraction is going to be 3, this first distance, out of the total, which is 7, 3 plus 4. So that would be the fraction of a ratio of 3 to 4. Okay? Now, one thing to add before we move forward, it doesn't necessarily mean the actual distance is 3 and 4 and 7. It just means that those are the ratios of the numbers, the ratios of the length. So you could think of like you could double all these numbers and the ratios would still be the same, or quadruple them, or whatever you want to do. But the important thing for right now is that you're able to go from a ratio to a fraction, or from a fraction to a ratio. Okay, why don't you try these two on your own? They're very similar to the ones we just did. So pause it here and try these out. Go ahead. All right, and here are the answers popping up here. If you want a quick mathematical way for how to do this, so if 1/4 is your fraction, your ratio is going to be 1, the numerator, and then the denominator minus the numerator. In other words, the distance between 4 and 1. So 1 to 3 here is your first answer. Now the second one, if you want a ratio of 1 to 1, what you're actually talking about is the fraction 1/2, right? Because you're doing 1 out of a total of 2. So think about everything we did with midpoint in the previous lesson. What we were actually doing is cutting lines into a ratio of 1 to 1, because this side is equal to this side. So again, it doesn't mean that the distance between these points is actually 1. It just means that the distances are equal, right? Or in this one up here, it means that this distance is 1/3 the times of this distance. All right, now let's see if we can find the partition point when we're given a graph. So we want to find the point that divides PQ into a ratio of 1 to 2. Okay, the best place I think to start is let's turn this number into a fraction. So a ratio of 1 to 2 is going to be 1 part out of a total of 3 parts, if you think of it like that. So we're looking for the point that basically cuts this line PQ at 1/3, right? So here's what we can do. Let's think about, well, what's the horizontal distance of this line? Let's count that distance between the x coordinates. So the horizontal distance is 6, right? 0 to 6, that's 6. So let's multiply that by 1/3. That's our fraction, right? And we can make that a fraction, 6 over 1, so 6 over 3. So that's 2. So 1/3 of 6 is 2. So that means if I go from my starting point and I count 2 units, I've arrived at my x-coordinate. So 2 has to be my x-coordinate. Now, because the y-coordinates are both 0, we can see that the y-coordinate's also 0, but the same rule kind of applies, right? So the point that cuts this line PQ in a ratio of 1 to 2 is 2, 0. Now, I just want to show you that if you think of the actual distance, 0 to 2 is 2, 2 to 6 is 4. You could see that as a ratio of 2 to 4, which if you reduce it, is a ratio of 1 to 2. Okay, so the actual distance reduces to the ratio. But here's the point we want. Okay, why don't you try this one out here on your own, and then we'll get you to the exit ticket. Go ahead, pause it here, give this one a shot. All right, and I want to go over this one for you because this is the most challenging one. So the ratio, we turn that into a fraction, 2/3. And then if we figure out the horizontal distance between these 2 points from -5 to 4, okay, that's going to be a distance of 9, right? So we need to figure out what is 2/3 of 9. So if we multiply 9 by 2/3, that's going to get us 18 over 3, so that's going to give us 6, right? So what we're going to do is we're going to go to our starting point. It's very important to return to the starting point. Let's count 6 units. 1, 2, 3, 4, 5, 6, right? And then we can do the same thing now for the y-coordinates. The distance between the y-coordinates is between 9 and 3, right? So that distance is 6. So if I multiply 6 by 2/3, all right, that's going to give us 4. So now what I want to do is I want to go from this point here, I want to go up 4. 1, 2, 3, 4. And you can see it takes us right to the line. So the point we want, point x, is going to be, if I just see where this point is, it's going to be 1, 7. So x is at 1, 7. Okay? And you can see here that u to x to v, that ratio is 2 to 1 because you have 2 parts for this 1 part. All right, if you want some extra practice, I've got a few Khan Academy problems that you can work with. If you prefer a written explanation, check out this link. These are both in the YouTube video that will kind of go more in depth into what partitions are. From there, though, you are ready to do the exit ticket. Good luck.